Hello, this is section 4.4 for Calc survey, and you'll be happy to see that we're going back to talk about profit, cost, and revenue. And I'm sure with us talking about max and mins, your boss would probably want to know when you're going to be able to maximize your profit and so forth, or minimize your cost. Now, just a quick reminder up here, profit is revenue minus cost. Revenue is price times quantity. Those are two really important equations that we're going to build off of. So the maximum or minimum profit can occur when your marginal profit equals 0. So if you think about this, remember this whole marginal profit, that's the derivative of your profit function. And where the derivative is equal to 0, well, yeah, that's going to be where you have a maximum profit, or it could be where you have a minimum profit, because that's where the slope of the tangent line equals 0. Another way to look at it, that's also what's up here. So if you do the derivative, so notice my profit and the little prime, that's the derivative, equals marginal revenue minus marginal cost. So I just did the derivative of all three terms. Well, if you then set this equal to 0, move over the marginal cost, so you actually also get a marginal profit or a max or minimum profit when your marginal revenue equals your marginal cost. And that's something you might have talked about in econ, and you said, why is this true? Well, here it is. It's a very simple derivation. You're just finding the derivative of profit, setting it equal to 0, because that's where the slope of the tangent line is going to occur. At your maximum and at your minimum. Yeah, that makes sense. So max or min profit does not have to occur at that point. It could also occur at an endpoint. So we'll keep that in mind. All right. Remember in the last section we talked about global or absolute extrema can occur at critical points within, but can also occur at endpoints. All right. So here's a visual for you. So I went ahead and graphed just a rough sketch of a revenue function. That's this line here, and then a cost function. Now, your max profit is going to occur when your revenue is much bigger than your cost. You want the biggest distance to get your maximum profit here. And notice my revenue is greater than my cost. Wherever this is going to be the most, that's going to give us our maximum profit. But watch what happens. If I sketch, so I took these graphs and I sketched the derivative. So I have a revenue function here. So notice that revenue, that derivative is just a horizontal line. That's the slope. That's marginal revenue. And then marginal cost, I notice I'm increasing the entire time. So notice it's positive. I start off concave down. So notice my derivative is decreasing, and then I switch to concave up. So now my derivative is increasing. So that's just a rough sketch of the marginal cost. All right, now we had two things happen. Notice your marginal revenue is equal to your marginal cost at two spots here. Well, that makes sense. You've got this distance when your cost is the farthest away from your revenue, but that's not what we want. That's not good. But that's this first one. And then you have another intersection point, and that aligns perfectly with this right here where you're getting a max profit. Oh, isn't that cool? Okay. So to the left of Q1, you'll notice that marginal cost is greater than marginal revenue. So you're going to want to tell the business, yeah, you want to keep decreasing, but you kind of have to get past this point. All right. Now, once you're past that point, though, here's where you realize you have your marginal revenues greater than marginal costs. So here's where, remember in the last semester, we would say increase production. You're trying to get to this point right here. So increase production. And then once you get past that point, that's where you'd say, whoop, you went too far, because now your marginal cost is greater than marginal revenue. You'll want to decrease production. All right, so generally last semester, we always started somewhere within this range and then talked about it here. All right. Now I did graph the profit function down here just so you could see. So our profit function would look something like this, where Q1 is where you're getting a minimum. See how you have a minimum there? And then here's where you're getting your maximum at Q2. Okay. All right, so to the left of Q1, marginal cost was greater than marginal revenue, therefore your derivative, your profit is negative. Shows you here. And then because Q1 and Q2, marginal revenue is greater than marginal cost, your derivative of your profit is positive, so you're increasing. And then to the right, Q2, marginal cost is now greater than marginal revenue, therefore your derivative of your profit is negative, so you're back to decreasing. So it just gives you some visuals of what's going on. And I think it's really good for you to see where that marginal revenue equaling marginal cost, yeah, that's going to tell you where you're going to get your max profit, but you have to be careful. It could also tell you where you get your minimum profit. All right. So I just wrote a little note to ourselves up here. So let's look at some examples. So it says a demand function is given here, where Q is the quantity of goods sold for price P. Find an expression for the total revenue. So this is all review. Revenue is price times quantity. So notice I plugged this function in for P and wrote my new revenue function in terms of Q. Okay. Differentiate, meaning find the derivative of R with respect to Q to find the marginal revenue in terms of Q. So I just simply did the derivative and then calculate the marginal revenue when Q is 10. So I plug in 10, that's the marginal revenue. That's how fast your revenue is increasing. Remember, this was $360 you're going to earn when you produce the 11th item. All right, calculate the change in total revenue when production increases from 10 to 11 units. So I did revenue at 10. I did revenue at 11, subtracted those and got 358. That's using the actual revenue function. Was that pretty close to what we found with our marginal revenue? Yeah. So it's a reasonable estimate for marginal revenue. Okay. All right, here's another example. Marginal revenue and marginal cost are given in the following table. Now, realize these are marginal revenue, marginal cost. These are all derivative values, slopes of the tangent lines. Use the marginal cost and marginal revenue at production at 5,000, so right here, to determine the production should be increased or decreased. So you immediately see marginal revenue is greater than marginal cost. That's a good thing. Increase production. Then estimate the production level that maximizes profit. Okay, so we want to maximize profit. So you need to be careful here. Find where your marginal revenue equals your marginal cost. And it looks like it's definitely 8,000. Yeah. But here's where I said be careful. You might have more than one places in your table where they equal each other. We saw that in this graph here, where that can happen. So you'll want to make sure that you're telling your boss to increase production and then decrease, so you know it's where you have a relative max. So coming back here, I noticed that marginal revenue is greater than marginal cost all the way up until we get to here. So we're saying increase production until 8,000, and then notice now you drop. Now your marginal revenue is less than your marginal cost. You would be telling them to decrease, therefore creating that maximum right there. So just be careful with some of the tables. You might have, it might also show where you have a minimum profit. Okay, and then down here, last one, the marginal cost and marginal revenue of a company are given in these functions, where Q is the number of items manufactured. To increase profits, should the company increase or decrease production for each of the following levels? So at 25, 50, and 80, I calculated the marginal revenue. Now it's just a number, so it's the same for all three. But then I calculated marginal cost. So I plugged 25 into this function, 50, and 80. And then you just go and compare. So at 25, you can easily see marginal revenue is greater than marginal cost, increase production. At 50, now your marginal cost is greater than your marginal revenue, you would say decrease production. Then at 80, now your marginal cost is a lot higher than your marginal revenue, so yes, decrease. But here you can see somewhere within this region, when we were saying increase, and then you switch to decrease, you're maximizing your profits somewhere within between 25 and 50 items. All right, so make sure you do your homework. The big takeaway is the fact if you want to calculate your marginal profit, you're setting that derivative of your profit function equal to 0. But if you want to maximize your profit, you can find where you maximize your profit by setting marginal revenue equal to marginal cost. But as I've said multiple times, be careful. It could also tell you where you minimize your profit. So just make sure you check. Okay. All right. Make sure you do your homework. Let me know if you have any questions.